In this video, we'll go ahead and take a look at some examples from section 7.4 on hypothesis tests for proportions. And we'll go ahead and look at problem 1 from the homework, and it says a research center claims that 24% of adults in a certain country would travel into space on a commercial flight if they could afford it. In a random sample of 800 adults in their country, 26% say that they would travel into space on a commercial flight if they could afford it. So at the significance level of 0.01, right, is there enough evidence to reject the researcher's claim? And we're going to complete parts A through D below. So remember that proportions, right, tell you which part or percentage of a population has a certain characteristic or who holds a certain belief. So in this case, we're looking at the percentage of a population of adults who would travel into space on a commercial flight. Okay, so this particular research center, right, believes that about 24% of adults would say yes, right, they would travel into space on a commercial flight. Okay, so then we look at a random sample from the population. So we look at 800 of these adults from the population. Okay, we found that 26% of the sample said that they would travel into space on a commercial flight. Okay, so the 26% and the 24% are pretty close. Okay, so it seems like a reasonable claim to make, right? That about 24% of the population would travel into space. Okay, so in part A, it asks us to identify the claim and state the null hypothesis and then the alternative hypothesis. Okay, so identify the claim in the scenario and then select the choice below and fill in the answer box. Okay. So again, you can read these answer choices carefully on your own. Okay, but the claim is saying, right, that 24% of adults in the country would travel into space on a commercial flight if they could afford it, right? That's exactly what it says. Okay, next we're going to set up the null and alternative hypothesis by making the most appropriate answer choice. Okay, so notice that in each of these, right, the symbol used to represent the proportion of the population is the lowercase letter p. Okay, so the lowercase letter p is always used to represent a proportion. Okay, so again, the claim is that 24% of adults in the country would travel into space. Okay, so that indicates that the null hypothesis must contain an equal to. Okay, so the only answer choice for the null hypothesis has the equal to symbol is answer choice D. So notice that it doesn't say like greater than 24% or less than 24%. Okay, if that was the case, right, if the problem said like, for example, greater than 24% or less than 24%, that would automatically become the alternative hypothesis. Okay, but it just says it claims that 24%. It's understood that the problem is saying that the population, or the percentage of the population that would travel into space is equal to 24%. Okay, that's what it's saying. Okay, so we put 0.24 here, so we change the percent to a decimal. Okay, that's always going to be the case, right? We change the hypothesized proportion into a decimal if it's given to you as a percent. Okay, and then in the alternative, right, the opposite of equal to would be not equal to. Right, so it's saying the proportion is different from 24%. Okay, so if this is not the case, then the proportion is not equal to 24%. Okay, so now we're going to go ahead and enter this information into StatCrunch. Okay, so we're going to go to Stat, Proportion Stats, okay, with one sample. Okay, we don't have the actual data, but we have a summary. Okay, and the first box asks us for the number of successes. Okay, so it's going to go back to the problem. Okay, so it tells us that there were 800 adults in our sample. Okay, so that's the number of observations, so that goes in the second box. Okay, it doesn't really tell us how many people in that sample, right, want to travel into space. Okay, it gives us the percentage that want to travel into space. Okay, so what we do in that situation is we take the percentage in our sample, which is 26%, okay, convert that into a decimal. Okay, so 26% as a decimal, okay, it's 0.26. Okay, you're basically moving the decimal point 2 places to the left to get 0.26. So you take that percentage as a decimal, multiply by your sample size, and then you get the number of successes. Okay, and if you get some sort of decimal when you do that, make sure you round it to the nearest whole number. Okay, so there are 208 people in our sample that would travel into space on a commercial flight. So that's what we're going to enter into StatCrunch for the number of successes, 208. Okay, remember we're doing a hypothesis test, so we're going to select this button, which is already selected. Okay, and our hypothesized proportion is 24%. Okay, so in the null hypothesis, it's equal to 24%. Okay, so the opposite, or the complement of equal to, is not equal to. So not equal to will be selected for the alternative. All right, and we can create a p-value plot, although that's not necessary. Okay, let's just quickly verify that we've entered the correct information. Okay, 24% is the hypothesized proportion. Okay, that's the claim. Okay, this is the null alternative hypothesis. That's what we should have in StatCrunch. Okay, let's go ahead and get the test statistic, the z-score. Okay, so we're doing a hypothesis test on the proportion. Number of successes is here. Sample size is here. The sample proportion is 0.26. So if you take the number of successes, divide by the sample size, okay, that's your sample proportion, okay, which is p hat. Okay, so I was looking for the z-stat, which is this thing here. Okay, we're going to round it to 2 decimal places, so it's 1.32. Okay, now we're going to input the p-value. Okay, which is 0.185, so usually p-values are rounded to 3 decimal places. And it indicates that here, so I'll round the answer to 3 decimal places, so it's 0.185. Okay, so in part C, we're going to decide whether to reject or fail to reject the null hypothesis. And then in part D, interpret the decision in the context of the original claim. Okay, so our p-value is equal to 0.185. So when you compare that to the significance level, right, we can clearly see that our p-value is larger. Okay, now if you want to, you can view the p-value plot. So this would be a two-tailed test, right? What's called a two-tailed test. All right, it's called a two-tailed test because the symbol in the alternative hypothesis, okay, is not equal to. But in any case, right, we're going to fail to reject the null hypothesis. So therefore, there is enough evidence to support the researcher's claim. Okay, so remember the claim in this case is the null hypothesis. Okay, we failed to reject, or we did not reject the null hypothesis. Okay, so therefore there is enough evidence to support the claim. Okay, so if that doesn't quite work, so I'm pretty sure this is correct. So we can say there is not enough evidence to reject. Okay, that would be the other way you can say it, right? There's not enough evidence to reject the researcher's claim. So let's do that instead. Okay, that's what you have to do. So if the option didn't work before, try something else, right? So if trying is enough evidence to support doesn't work, right? Then try there is not enough evidence to reject the claim. Okay, so then it completes example 1. Okay, so let's go and do one more example. So this is problem 4 from the homework. And it says that a research center claims that more than 24% of employees in a certain country have changed jobs in the past 4 years. In a random sample of 280 people from that country, 84 have changed jobs in the past 4 years. So at a significance level of 0.05, okay, is there enough evidence to support the research center's claim? And we're going to complete parts A through E. Okay, so you may have noticed that the 24% in this problem was the same percentage that we saw in the previous example we did. Okay, so that's a pure coincidence. Okay, so for these problems in this section, right, this percentage, okay, won't always be 24%. It's going to change from problem to problem. Okay, but in any case, right, we're asked to identify the claim and state the null alternative hypotheses. Okay, so the first part here is to identify the claim. So it says more than 24% of employees have changed jobs in the last 4 years. So reading the answer choices, you're going to select the most appropriate answer choice. Okay, that fits the description of the claim. Okay, so it appears to be answer choice B, but go ahead and read these on your own carefully. So let's go ahead and check that. Okay, so now we're going to select the null and alternative hypotheses. So you want to pay attention to the wording used in the claim. So more than, okay, would mean that we're going to use the greater than symbol in the alternative hypothesis. Okay, likewise, if it said less than, right, we would use the less than symbol in the alternative hypothesis. Okay, so let's look at our answer choices here, right? Okay, so once again, we're looking for the answer choice that has the greater than symbol, okay, in the alternative hypothesis, okay, not the greater than or equal to symbol, like answer choice E, but the strictly greater than symbol. So it looks like answer choice F, okay, so then the opposite of greater than would be less than or equal to. All right, so then we're going to go and type in that 24% in the two boxes here, so convert it to a decimal, so it's 0.24 here in the top box and 0.24 in the bottom box. Okay, so now it's asking us to find the critical values and identify the rejection regions. Okay, so this problem is slightly different than what we've been doing before, right? Where we calculate the p-value. Okay, so we're going to calculate the critical value. Okay, making a note that since we use the greater than symbol in the alternative hypothesis, right, then this makes this a right tail test, okay, which means the rejection region is in the right tail of the probability distribution. Okay, so quickly, okay, going back to the null and alternative hypothesis, right, you see how the symbol used in the alternative hypothesis is strictly greater than, okay, and that symbol points toward the right. Okay, so the direction of the symbol, right, indicates whether it's left-tailed, right-tailed, or two-tailed. Right, so since the greater than symbol points toward the right, it means the rejection region is in the right tail. Okay, so let's go and go to StatCrunch. Okay, we're going to go to stat, calculators, normal. Okay, so we're using the normal distribution. Okay, and the mean and standard deviation is 0 and 1. Okay, so since this is a right tail test, we're going to select greater than or equal to, and then enter the significance level in this box here. So you get the critical value. Okay, so the critical value is 1.64. Okay, and we're going to round that to 2 decimal places, so 1.64. This says identify the rejection region. So again, if you look at our graph here, the rejection region's in the right tail. So it's where Z is greater than 1.64. So where Z is greater than that critical value. Okay, since it's toward the right. Okay, now we're going to go ahead and find the test statistic. Okay, so once again, go into StatCrunch. We're going to go to Stat, select proportion stats with one sample, okay, with a summary of the data. Okay, and again, according to the problem, the number of successes was 84. Our sample size was 280. Okay, and then the proportion in the problem was 0.24, and then the greater than symbol was in the alternative hypothesis. Okay, so our test statistic rounded to 2 decimal places is 2.35. And that's what's going to go in this box here. Okay, we're going to compare that to our critical value. Okay, so since 2.35 is greater than our critical value, and this is a right tail test, making the rejection region in the right tail of the probability distribution, right, then we reject the null hypothesis, so there is enough evidence to support the claim given in the problem. Now, if the test statistic was not in the rejection region, then we would fail to reject